Today we're going to look at LINQ, L-I-N-Q, and we've used LINQ expressions for a while. Today we're going to look and do a deeper dive into them and study some examples and see how they work and understand the whole rationale behind LINQ. 1 second. First of all, the word LINQ, what does it stand for? It stands for Language Integrated Query. All right, let's explore what that means, and let's explore why that's important. Prior to LINQ being used, most often we would interact with databases using a language called SQL. And in SQL, the commands were put in strings. So if we wanted to access, for example, all the customers in the customer table, we would create a string that said select star from customer. Now, what's wrong with that, you might wonder? What's wrong with that relates to the kind of errors that you would get under SQL, or rather the kind of errors that you were at risk at getting running SQL. There are a couple different kinds of errors that you can have. There's compile errors, and there are runtime errors. Of the two, compile errors are far preferable than runtime errors. And why do I say that? Well, if I'm writing code and I have a syntax error and I spelled the word select wrong, for example, in a LINQ query, there's a select function in LINQ that I can use. And if I spell the word select wrong, it's going to give me a red squiggly line, all right, underneath it. And it will tell me that it's not valid. And therefore, me as a developer can go in before I release this product, I can go in and clear up all those errors, all right? In fact, you need to clear up all those errors before you can even compile your code. So for that reason, it's better to get compile errors as opposed to runtime errors. Especially runtime errors are errors that occur when the program is running. And usually they depend on circumstances. In other words, your customer query will work if you sort by first name, but it gives you an error if you sort by email address, just to make up something. So you, as testing the software, if you don't do a really thorough job, and believe me, that's hard to do, to test every possibility. If you don't do a great job in testing, some of these runtime errors are going to slip through, and some of them are going to occur when it's running. And they're not going to occur to you. They're going to occur to your customers, the people that are using your website. And what will they do with those errors? Well, it depends. They might just go to another site. If you were a sporting goods store and you got runtime errors when you searched a certain way, a customer's always say, okay, forget it. I'll go to a different sporting goods store. If they do report the error, they might not give you great information about what caused it. You know, they might say, hey, the program blew up when I was looking for tennis shoes. You know, it's not very descriptive about exactly what you were searching for. How did you say to have it sorted? Were there any other sorts? That sort of thing. All right. So you want to get compilers because you can spot them as a developer and you have to fix them. All right. So any error that exists anytime the program blows up is not because of a compiler, because you fixed all the compilers. I'm talking about an application that's in production. Now, SQL statements, all the compiler knows is that this is a string, and this is a valid string. It doesn't look to see if it's a database command. It just knows, hey, there's supposed to be a string here. There is a string. If I spelled select wrong from it, the compiler isn't going to notice there's anything wrong with that because that is a valid string. All right. The compiler doesn't look inside the string and say, oh, this is supposed to be a SQL statement. Let me look for errors. It doesn't do that. All right. Instead, when will this error happen? This error will happen when you go and run it. So you'll get a runtime error. And again, this is an extremely simple case. You really wouldn't have this kind of problem. You ought to notice it the first time you tested the customer query, but even more intricate ones, it doesn't know what the SQL statement is supposed to be. So as long as you have a valid string, it's okay. Whereas with LINQ, LINQ is language integrated query, and we'll see examples of that. That means that the commands are part of the language. So in SQL, the commands were put in strings. In LINQ, for our purposes, they're put into C# instructions. And therefore, those instructions can be compile checked to make sure that they're indeed valid. The other thing about LINQ that is good is you can use LINQ on any source of data. SQL only works with databases. LINQ can work with databases, but other data sources as well. So it can look at an XML file and query that. It can look at a JSON file and query that. It can look at an array that was in memory and query that. So we use the same language to query the data source regardless of how that data source is stored. And that's a very positive thing to be able to do. Okay, so what about LINQ? Let me pull up some examples of LINQ. I made an alteration to the whatever, I want to say Costco University example. I know it's not that. Let's look for LINQ examples, Entity Framework Core. Here are some examples. If I wanted if there was a table called blogs, an entity called blogs, and I wanted all of them, I could simply set a variable called blogs and get the list of those. I could say if I only wanted one of them, like let's say I just wanted the one entry from it, I could do and pull out the blog entry of whatever was selected. If I wanted to check blog links, I could look for where the URL contains .net. All right. There's two styles of writing LINQ queries. There's a query syntax and there's a method syntax. And this will show you which is which. Maybe. Oh, kind of shows you. If we had a list of names, again, this is a list. This could be a database table, though. This is a query syntax to pull all the names where the name length is less than or equal to 8. And it's done two different ways. This is a query syntax. And the reason it's called a query syntax is it's similar, not the same, but it's similar to SQL queries. An SQL query would typically say something like select some things from the name of the table, where, and then you'd have a where clause. Well, this looks a lot like it. Just plain statements, but they are statements that are embedded in the language. So if I spelled something wrong here, it would give me an error. All right, from name in list of names where name.length is less than or equal to 8. And from that, select name. Really, this is just a SQL statement. If some of you have studied SQL statements before, just sort of rearrange the pieces. A little bit more concise of doing it, and the way I see a lot of people going is using this called the method syntax, where you call methods. And think of methods as like being a pipeline, where we go and apply certain things to the pipe. The where clause, what it does is it filters out things. So we take the list of names and we call the where method. What does that do? It takes that list of names and only gives you the ones where the name is less than 8. The length of the name is less than 8, that is. So I don't really care which one you use. You actually can supposedly mix and match. I'm not sure why I would do that. But use whichever one you prefer. I kind of lean towards this one with these lambda expressions. Let's look at these lambda expressions for a minute. I create a function that accepts an integer. I don't know why it says 2 integers, but whatever. Square says take that integer that's given to it, and this means goes to, or another word for that, or is transformed into this. So x is transformed to x squared, and then x squared gets outputted. So that's what the lambda expression is. On this side of the lambda expression, these are the data that you're providing the lambda expression to operate on. All right, or transform the list. In this case, what is it? Well, it's from whatever came before it in the pipeline. Now, in this case, this is the first thing in the pipeline, so the argument to this function is the list of names. If we wrote a different lambda expression after this, the input to that expression would be the list of names that got filtered. All right. For example, if we were to sort these in a particular order, all right, that would take the results of this function, however the pipeline has been transformed, the data in the pipeline transformed, and then do a sort on it or whatever. And this is the operator that we're doing on it. So in a way, you actually pass to the where function a little snippet of code. All right. These are not unique to C#. All right. In the advanced Java class that I teach at Akron, they use these a lot. These work on any sort of list or enumeration or enumerable items, not enumeration. And there you go. It's good to be able to identify this and understand, like, why doesn't his query look like my query? Well, they may be using the query syntax and you might be using the method syntax. So just be aware that there's two kinds of syntax that you can use. And as far as which one you use, I don't really care. All right, let's go to this example. Here it is. I have so many files. And I actually posted two versions of this. One is the original version that I posted, and one is the better version. The better version actually addresses an inconsistency between doing them two different ways. I did the query syntax on one, and it got slightly different results if there were more than one instructor for a course. And therefore, I changed them to be consistent. All right, that's really all I did. So let's run this and let's see what I did. I created a roster page. And I've done everything I needed to do to set this up. I updated the database and all that. So if you download this example, you need to go in and update the database. But I'm going to go and run this. It's going to do its thing. And if I click on courses, I have two different ways of getting the roster. One is using the method version of the query. The other is the query version of the query. And what that will do is that will show me the course, the department, the name of the instructor, and their office. In the case that there's more than one, it shows them next to each other. If it's missing, if they don't have an office, it shows blank. And again, I spelled instructor wrong. And these are just a list of all the students that are in there. Now, first of all, why would I create a page like this? I'd create a page because, and this is important, this is relevant to your project. When you're thinking of the stuff that you're going to put in your project, think of things that would be useful for the users of your application to do. In other words, if you gave me this application and this would show me the list of all the students and I could search by name, that's not terribly useful to me. I'm not interested in every single student that goes to the college, even if they're paged into separate pages. I just want the students in my class. Now I can get that in a roundabout way somehow, I think, if I go to, see if I go to details. This is useful. This would be like your course schedule. But the details here aren't terribly useful for the instructor. And neither is the details for the course, because it doesn't show me all the students. So I decided to make something that I would anticipate people in my users, one of the categories of users anyhow, would find useful. So don't just send me for your project a project with completely all there is to it are things that you scaffolded, the CRUD operations: create, retrieve, update, and delete. Don't do that. Go beyond that. Think of ways that you can combine the data to be useful. All right. And that's what will take your project from being like, okay, I mean, I'm not going to knock it. If it works, you'll get some credit for it. But that might be a B project. An A project will be one that takes and actually goes beyond just giving a place to enter data, a place to see the data, and so on. Go beyond just the stuff that you scaffolded. And that's what I attempt to do with this. I did something that I thought would be useful. All right, let's look at the code. And for simplicity's sake, I coded everything right in the page. I didn't like make a secondary file or anything like that. That sometimes can cloud the waters a little bit. Okay. It's under pages, courses, roster, and roster one. We'll start looking at roster one, which is the method syntax. All right, I'm going to look starting at the model. The model has two things in it. Remember, these things are things that are going to be available to the Razor page. All right. So we want to make the course and we want to make the enrollments available to the page. Why? Because we want to see the information about the course on the top of the page, the information about the enrollments going down in the list. Okay. We'll come back to the async later part of it. If not today, possibly in a future class. What that means and what the benefit of that is. All right, but I don't want to lose momentum here. So let's look at this function. The roster page, of course, needs a valid course ID. So if there is not a valid course ID, if the course ID is null, then it's simply going to return a page saying, an error page saying it's not found. Now we have this sort of stream of functions. And we're using dot notation all the way down. And what that does is that takes the original thing and transforms it in such a way. Then transforms it. Then transforms it. Then transforms it. And finally it grabs the first thing that I want from it. I also want to make sure this is actually redundant because I have the filtering in two places, but we'll let that go. I could probably take away one. I don't want to mess with this because I worked hard getting this to work, and I'm afraid I'll screw something up by changing it. But just know you probably don't need both of these. Okay, so underscore context, courses. What does that mean? What is our context? Our context relates pretty much, corresponds to a certain set of entities. Another way to put it, certain entities that map to a database. So an oversimplistic view can say that this context, all right, is our database. That gets set when this is created. Gets set in the constructor. So whoever calls this is called a dependency injection. Whoever calls this gives this what it needs. This needs a context. It gets passed in. So let's put some comments to the side here. And this is a useful exercise. What does this do? This is a list of all courses. If we left it there, that's what we'd get. If we outputted, we'd get a list of every course. But we don't leave it there. We transform that stream by taking the output of this, which is a list of courses, and apply this function to it. And this says whatever the input is, that is the list of courses, gets transformed with a where clause or where function to only give me those that match the course ID. That matches the ID that we passed into it. All right. So what this does is this filters list to only show desired course. This ID, remember, came from the link that was on the index page. That link is a link that includes the ID. So what we have at this point is we have a filtered list. It should only have one course in it. All right. Now, if I was only interested in course attributes, I could end it here and again go my way, but I'm not. I want to, if you notice here in the model, the course has a department. And so it has a navigation property for department. Another word to say that is part of a course is the department to which it belongs. And that is a department object. It also has a department ID that's defined as an integer. All right. That also establishes the foreign key. I didn't have to identify this as a foreign key. It goes by convention. If it finds a model called this or the plural of this and a field called ID, if that matches the name, it assumes it's a foreign key. All right. So when I say include department, what that is saying is I want to include, phrase that, I want to fill up the department object for all the courses. And remember, there's only going to be one course, so it fills the department for the one course. If we look, all right, so list of everything, filters out only the desired things where the ID matches, fills in with the course, the department information. Now we're filling in the course assignments. Little difference in the course assignments, though, is that the course assignments is a collection. It means that there's more than one of them, and it's called course assignments. So we're transforming it, and this is going to fill up the course assignment part. Of the course. So notice how this stream of one function that it passes its output to the other function's input starts with a list of all the courses, then we do some things to it. We filter out everything that we filter to include everything that matches the ID. We fill in the department. We fill in the course assignments. Now here's a then include. What's the difference between the then include and the include? Well, the then include doesn't, you use the then include when the data that does the matching is in something that you included. In other words, there's no instructor ID in courses. So I could not say include instructor, include I instructor from the list. This only exists in the course assignments. So after we've included the course assignments, then fill up the course assignments instructor information. If we set up the model right, and if we define the foreign keys, and if we follow the convention like we've been doing, it figures out what the relationships are. And all we have to do is say include instructor. We don't have to specify what in one table matches up because the model already knows that. All right. We have another then include because from the office assignment comes from the instructor. So now, what do we have here? This fills up instructor on each course assignment. This fills up the office for each instructor. So what do we get? We get a list of courses where the department's filled up, the course assignments are filled up. Notice we did not include the enrollments, so the enrollments are not filled up in this example. Could we do it? Yeah, we probably could, but I chose to simplify things and do 2 queries. So we have a list of course objects that have the department and course assignments filled up. Each of those course assignments has its instructor filled up. Each of those instructors has its office filled up. So we get this giant chunk of data that relates these entities to each other. At the root, it's a list of courses, but it follows those navigation properties to link up the tables that are related, at least the tables that we're interested in. And what do? We pull the first or default. All right. Since we have that up there, we don't need this here. I think I can get by with that. Let me run this and make sure it still works. I'm not going to upload a third version. You can do that. You can make the change on your own if you want to. Yep, still works. How would I test this thoroughly? I'd make sure I included something, and I did do this, by the way. I might not have entered all the data, but I would test to see what if it has one instructor and the instructor has an office? What if it has an instructor and the instructor doesn't have an office? What if it doesn't have an instructor? All right, make sure all those scenarios worked. Make sure that there's multiple students, multiple instructors. See if there are multiple instructors, it gives me a list of them, along with the list of multiple students. Okay, where I'm going to leave this, we're not going to go on in the model just yet. We're going to pop over to the Razor page itself. Because what we have is we have a course. Actually, I said course, courses, and up to this point, first default or async, there should only be one course, so it's okay to say, give me the first one. All right. This narrows down. I guess I left the comment out. This makes, selects a single object. And there should only be one course with that ID, so that's not a problem to give me the single one. So when we're done with this course object has all of its course assignments filled out, has all the departments filled out, has all the instructors for the course assignments filled out, has all the offices for the instructors. Now let's look at the code. If that didn't get filled in, all right, then I got a problem. Oh, I'm looking at the wrong one. I was getting confused. I'd say that looks more like the query example. All right. This is more like it. All right. Now, to display that first line, the first line is pretty much everything we have in the screen right now. Where is it going to pull the data from? It's going to pull the data from that course object in the model. How do we refer to that course object in the model? Model.course. What do we want from the course? We want the title. So that's going to display the title for the course that got retrieved and put in the model's course variable, which after all is a course. Then we're going to retrieve the department name. Now, the department name doesn't live as part of the course. It lives in the department associated with that course, and the field is called name. This is what I mean about errors. Let's say I spelled name wrong. Gives me an error. All right. Gives me an error. It knows that there's no such thing as NAMME in the department entity, right, in the department model. So it knows that that's an error. If we made a similar error to that in SQL, it wouldn't know it until it ran the expression. Now, with course assignments, we might have more than one. Oh, the instructor, yeah. For the course assignments, we may have more than one. So we loop through those, and we output the instructor's full name. So now we're not looking at the course, we're looking at the course assignments that are part of the course, and we grab from that item the instructor's full name. So we're looking at the course assignment, instructor full name, and we do a similar thing for office location. Remember, the course assignments in the course object are a collection. Therefore, if we want to get all of them, we have to loop through them. So we're looping through all the course assignment objects that is part of that course that got filled in. All right. and we're displaying for that because we filled in the instructor for each course assignment, we can say, give me that course assignment's instructor's full name. We do the same thing for the office. I suppose it might be possible to combine these, but I chose not to. I wanted to show all the instructors and all the offices. So I looped through that twice. Loop through it to pull all the instructors, loop through it to pull all the instructors and the office. I could have include the office to be printed out here. Then it would show instructor office when there's multiple. Non-breaking space simply puts a little space in between the names of the instructors and the names of the offices. Now, let's look at the enrollments. Enrollments is a little simpler. All right. We say, give me a list of everything from the database in the enrollments table. Give me all the enrollment entities. We're going to filter out, and we only want those enrollment entities. We only want the output of this statement, which is a list of enrollments. We're going to transform that by filtering and give me only the ones that match the ID of the course. And for each enrollment, I want to include the student. Because we define the entity correctly, the entities correctly, and the database is generated from those, there's no need to, like in database terminology, of doing a inner join or an outer join or anything like that. All right, it handles the navigation property. And then to list async. The difference between enrollments and the course is the course query only returns a single course. The enrollments returns an enumerable, that is a list. Now, as I said before, if I spelled where wrong, I will get a compile error. It warns me, it tells me that it's wrong, and I have to correct it. If in the old days with SQL, if you had spelled the word where wrong, it would not know that until you actually went and tried to run that query. But this, again, is integrated with the C# language. So these are C# instructions. Likewise, if we spelled this wrong, no such thing in the enrollments as something called course with 2 S's ID. So I know, oh, got rid of the wrong letter. So I know when I'm done, this query isn't necessarily correct. There's still ways to make problems, all right? There's still ways that I could make a mistake, all right? But I know syntactically at least it's correct. It's not going to blow up because I got a column name wrong or because I spelled an instruction wrong. If when we get to the bottom of this, if there's no course, if the course didn't get filled up from this query, we return not found. Otherwise, we return the page. Let's look at the page for the students. For the students, we simply loop through all the enrollments, all right, that are in that list, in the enrollments list, and give me, for each enrollment, give me the student, their first name, which we can do. Now, if I didn't do this, let's take a look. Let me make a mistake on purpose. I'm going to eliminate the include statement. All right. Syntactically, that's still correct. This is what I mean by this isn't a foolproof, perfect way to do it. But again, it does catch a lot of issues. If I run this now, I bet I know what it's going to give me. It's going to give me the the dreaded null object exception. I go to course, go to roster method. I stand corrected. It didn't give me a null object, but guess what? Didn't display the students either. So this roster didn't work. It knows that there are 3 enrollments, but it doesn't know what the students are for those. Why is that? Because we didn't include, oops. We didn't include the include statement that says, hey, for these enrollment records, I'm also interested in the students, so please fill those up. All right. So you can query, and again, the reason you do this is because depending on what you're trying to do, you may only want information from the course entity. So I would not do any includes then. I only do the includes if I want to include the related data to it. If I want to fill up those navigation properties with their related data. All right, I know this is a lot to absorb. This took me a while to wrap my head around after doing, I don't know how many years of coding with SQL statements. But I slowly saw the light and see how this is beneficial to you as a programmer to do it this way. Again, these Lambda operations are in a lot of different languages as well. So again, I would, and they typically work with collections. They typically work, like I said, with a pipeline where you take the output of one operation, perform the next thing on it, the next thing, and so on. All right. We have another example of this that will wait until next week, I think, because we only have a couple minutes left. And that is where I used the query syntax, where this looks sort of like a SQL statement, doesn't use any of those Lambda expressions, and it does essentially the same thing, although it does it in a couple extra steps, or does it in like one extra step. And we'll see that next time. By all means, download this. Download this and study it and try to understand it the best you can. What I would like everyone to do in this class is to shoot me an email that specifies what we've studied so far that you're having trouble with. It might be these Lambda expressions. It might be, you know, who knows what. So try to get that to me as quick as possible, and I will use that. I'll use the information I get to try to plan some of the next lectures that we have. We really only have 3 lectures left, all right, because this is week 12. We have week 13, 14, 15, and then the final project is due the last week. Remember, I am available for conferences or for, you know, online meetings. I can also come in to see you in person if that's what you prefer. Usually most people, because of their busy lives, prefer to meet with me online. You can share your screen, show me exactly what's happening, and so on. But remember, it's okay to ask me questions and problems, and it's okay to schedule a meeting with me if you have more than just a handful of questions. All right, that's all I had. We'll see you next week.